Good morning, students. Arbans, Danish, good morning.
Good morning, sir. Good morning, sir.
Good morning. How are you?
Fine, sir. And you?
I'm also fine. Now, today I'm going to start new topic, bootstrap refrigeration air cooling cycle with evaporative cooling. Okay. So, from the PPT, I am going to show from the PPT here screen. So, is it visible to everybody? This PPT?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Now, beta, today I am going to start with this bootstrap air evaporative cooling system. So last time we have done bootstrap cooling system, but in this case we have also added this evaporator. Okay, so look at here from the figure. First of all, ambient air is entering inside jet where ramming action will be there. When ramming action will be there because of their internal friction, what will happen? Their pressure and temperature will get increased. Okay, due to internal friction, and it is due to internal friction and irreversible process. Okay, after this, it will passing through the main compressor where its pressure and temperature both will get increased. After this, look at here from main compressor where both its pressure and temperature will get increased. Some of the air will passing through the combustion chamber. After passing through combustion chamber, some of the air will passing through this gas turbine. Okay, so this air firstly pass through this first heat exchanger. There will be two heat exchanger in this case. Look at in this figure. So the two heat exchanger, when hot air is passing through first heat exchanger, it will cool down with the help of this ram air. Ram air, which is supply over this tube, which is taken away the heat and go to the surrounding. Okay, so this means it will help to cool down the temperature, because at high altitude the pressure will also get reduced. Okay, so what we will do, we have placed a secondary compressor to increase the pressure. Okay, so secondary compressor is also there. Now after compression, again its pressure and temperature will get it. After this, it will passing through the second heat exchanger. The second heat exchanger, the hot air whose temperature and pressure are also increased, is cooled again with the help of this rammed air. Okay, now look at here in this figure. Again, it is cooled with the help of rammed air, second heat exchanger. Now, I have already told you about a evaporator in which water, ammonia is also present, and at when the pressure is low, the water is boiled at 40 degrees centigrade. I have already told you, it means when it will boil, that then the remaining effect will be cooling effect. So when it will pass through this evaporator, it's the temperature of the air will also again get reduced. After this, it will passing through this turbine, cooling turbine. Okay, so when it will passing through this cooling turbine, then again its pressure and temperature will get reduced, because expansion process will be there, throttling is there. When it will be passing through cooling turbine, its pressure and temperature will both get reduced. Okay, so after this, it will passing through the cabin. Then from after this, it will passing through the cabin. Okay, so look at here. After this, it will passing through the cabin where it will take the heat load. Okay, so where it will take the heat load. So after, now look at here. In this system, two heat exchanger and one evaporator is okay, and this evaporator is placed in between turbine and second heat exchanger. Okay, and this cooling turbine also helping running the secondary compressor. So everybody note down this figure. I am going to draw this figure on the blackboard, so everybody know what is the working. Everybody come to know how this works, how this bootstrap evaporative type cooling system works. So look at here on the blackboard. So I am going to draw this figure. This ambient air. This is the ambient air, mean outside atmosphere air. When your air is moving, this ambient air is passing inside the jet and the ramming action will be there. Here's the ramming action. Ramming action. With the ramming action, what will happen? Both its pressure and internal friction. This is your main compressor, turbine, combustion chamber. Some of here will pass it through this combustion chamber, which help in running this turbine. Okay, and this turbine is connected with main compressor. Okay, after this, some of the air will passing through the first heat exchanger. So this is your first heat exchanger. When it will passing through your first heat exchanger, so this first heat exchanger is cooled down with the help of ramming air, which is coming from the this is ramming air whose temperature pressure is much reduced as compared. If I will compare, whose temperature is lesser than the air which is coming from the main compressor. So when this air will overflow over this pipe, then it will take away the heat from there, and after this it will move to the atmosphere. Okay, after this it will move to the atmosphere. After this, again it will pass through its pressure, and it will pass through this heat exchanger. Its pressure will get reduced. Then we will also supply this secondary compressor. Secondary compressor is there, which is used to increase the pressure and temperature of this air, because at a higher altitude pressure will get reduced. So to increase the pressure, we will introduce secondary compressor over here. So look at here. After compression, both its pressure and temperature again get increased. Okay, again it will be cooled with the help of this ramming air. Again with the ramming air, again after cooling, this ramming air go to the atmosphere. After the, as everybody, after this, next is your evaporator. Evaporator is there, in which evaporation process, everybody knows the evaporation process will be there. Then remaining effect will be the cooling effect. So as everybody knows, the water is cooled at high altitude. At if I will talk about if your jet plane is flying at 20,000 meter height from the ground, then your water will boil at 40 degrees centigrade. Okay. So look at here. When this air is passing through this evaporator, it will get cooled, where both its pressure and temperature will get reduced. Okay, after this, it will pass through the cooling turbine. So this is your cooling turbine. Cooling turbine. So this is your cooling turbine. When it will passing through cooling turbine, both its pressure and temperature will get reduced. Okay, both its, because throttling process is there, expansion process is there, and both its pressure and temperature will get reduced. After passing through this cooling turbine, this less pressure and temperature air is passing to the cabin. Okay, from where it will take the heat load. Okay, when it will take the heat load from there, so then what will happen? Its temperature is going to increase. Okay, so and this cooling turbine is helping in running this secondary compressor through this reduction gear. So reduction gear also there. Okay, and directly it can also, if a reduction gear is not there, you can directly run this cooling turbine is directly running this secondary compressor. Okay, so this is the main diagram of bootstrap evaporative air cooling. Bootstrap evaporative. Everybody note on this diagram. Hurry up. Hurry up. I'm going to raise it. Now I am going to draw.
Excuse me, sir.
Yes, yes.
सर जूम एबल करिए ना सर, वो जूम ही नहीं हो रहा सर.
कौन सा बेटा?
वो ब्लैक बोर्ड, व्हाइट बोर्ड
ठीक है, ओके.
जूम ही नहीं हो रहा सर. फुल स्क्रीन करिए ना, जूम हो जाएगा उसके बाद.
जूम तो मेरी फुल है बेटा इधर. और कैसे करूँ? फुल स्क्रीन है बेटा इधर.
ठीक है सर, उसका प्रॉब्लम हो गया कुछ इसलिए.
ओके सर.
Is it visible to everybody? Screen is visible? Okay. Now draw the TS diagram. Everybody, draw the TS diagram. So beta, I have already told you in previous lecture, if you want to solve any type of numerical, first you have to draw the TS diagram. Then you will be able to solve that numerical. Then look at here in this case, how to draw the TS diagram. Temperature and entropy diagram. So look at here, we have ambient air pressure, next we have cabin pressure will be there, then we have ideal ram pressure will be there, then we have actual ram pressure, next, so this is the line, pressure line, this is your main compressor line, main compressor, look at it here, this is your main compressor line. Pressure line, and this is your secondary compressor pressure. So all these pressure are there. Number one, we have ambient air through which your air is entering inside the jet. So look at here, when it will entering, then its pressure and temperature both will get increased from 1 to 2. But in actual, it will increase up to this 1 to 2 dash actual ram pressure. Okay, where here that now after this it will passing to the main compressor 2 dash to 3, but due to internal friction irreversibility will be there, so this will be your isentropic compression and this will be your actual compression when it will passing through the first main compressor. Okay, then after this it will passing through the first heat exchanger where it will lose some of its heat from 3 dash to 4. Okay, so here it will lose some of its heat from 3 dash to 4. Okay, then secondary compressor is there which is used to increase the pressure and temperature again. So here 4 to 5 again increase the pressure and temperature of the air which is coming from the main compressor. Then due to again internal friction actual pressure and temperature increase will be 4 to 5 dash. After this, it will passing through the first heat exchanger, a second heat exchanger, 5 dash to 6, when it will passing through the second heat exchanger. Or you can write it also 5 double dash. For second heat exchanger, 5 double dash. You can write with 5 double dash. Then after this, evaporator. When it will pass through the evaporator, then its temperature also get reduced from second evaporator. Then look at here. First heat, second heat exchanger, its temperature will get reduced. After this, again passing through the evaporator, where again its temperature will get reduced at constant pressure. This is the point 6. Okay. So this means after this, the air is passing through the cooling turbine. When it will passing through the cooling turbine, then its pressure and temperature both will get reduced from 6 to 7. 6 to 7. Look at here, 6 to 7. But due to internal friction, actual pressure and temperature reduced is up to 7 dash. So look at here, 7 dash. Okay. Now again, it will passing through your cabin, from where it will take the heat load. So 7 to 8, when it will passing through the cabin, from where it will take the heat load, 7 dash to 8. So everybody note on it, 7 dash to 8. When your air is passing through the cabin. After, when it will passing through the cabin, from where it will take the heat load, its temperature is going to increase. Look at here. The temperature of air is 7. Here is T7 dash. Here is T8. So you can note down every temperature from this temperature line. So you can note down every temperature. Okay. So after this, its pressure and temperature after taking the load from cabin, it will again pass to the atmosphere. So this is all about the TS diagram of your bootstrap evaporative type cooling turbine system. So everybody note on it. Hurry up. So this type of a bootstrap is mainly used for transport type aircraft system. I have already told you last time. So transport type system, this system is mostly used. So everybody write down the formula mass of air. So what will be the formula of mass of air, which is passing through the refrigerating space? Or once you tell me, what is the formula of mass of air? Anybody know?
210 into Q divided by CP 56 minus T5.
No, here look at here where refrigeration effect will be there.
So T8 minus T7 dash.
Yes, look at here. This is the refrigeration effect in this case. Look at here from this figure. 210 into Q divided by, tell me, CP.
CP.
Yes.
T7 dash
T8
minus
minus T7 dash.
T.
8 minus 7 dash. Look at here. Do not cramming any formula. First, you have to draw this figure, ES diagram. So what temperature is coming over here? So you have to mention that temperature in the formula. Okay. So here T8 and T7 dash. So T8 minus T7 dash. This kilogram per minute air, cooling air is passing through your cabin, from where it will take the heat load. Okay. So what will be the formula of power? Tell me. What will be the formula of power?
MA into CP under bracket T3 dash minus T2 dash by
MACP?
60.
Yes.
T3 dash minus T2 dash.
T3 dash minus T2 dash. Very good. Divided by
Or whole divided by 60.
whole divided by 16. This will be come into kilowatt. Okay, beta. And what about COP? COP again 210 into Q divided by P into 60. 210 into Q divided by P into 60. So this is all about we can find out the mass of the air which is passing through your refrigeration system. Then we can also calculate power of the system. And last one, we can find out the COP of the system. Okay. So next, again,
एक्सक्यूज मी सर
बोलो बेटा.
सर एक बार 6.6 से लेकर 7 डैश वाला एक बार फिर से बता दीजिए ना सर.
Okay, okay, बेटा. Don't worry, मैं बताने जा रहा हूँ. So look at here, बेटा. When your this cooling air is passing from a evaporator passing through the cooling turbine after evaporator, then what will happen in evaporator in cooling turbine? Cooling turbine throttling process is there, expansion process is there. When expansion process is there, then both its pressure and temperature will get reduced from 6 to 7. But due to internal friction, its a temperature is not up to T7. Its actual temperature is 7, somewhat more than the actual, more than the ideal pressure. Ideal pressure. Okay.
अरे
Sound
साउंड
ही नहीं
बहुत
आ रहा
डिस्टर्ब
है.
आ रहा है सर, कैसे?
साउंड ही नहीं आ रहा है सर. साउंड
कौन क्या?
योर वॉइस इज नॉट क्लियर सर. देयर इज डिस्टरबेंस.
It is okay, yaar, from here. Let me see first. Now next is your reduced ambient air. So everybody draw this figure first. Hurry up. Reduce ambient time. So look at here in this case. Again, the reduced ambient air system include 2 cooling turbine and 1 heat exchanger. So in this case, 2 cooling turbine is there. Look at here in this figure. First is where is my cursor? Okay, which is helping in reducing the temperature of rammed air. And second is there, which is also used to for throttling process. Okay, so both 2 turbines are there and 1 heat exchanger. In between these 2 turbines, there is 1 heat exchanger. The air reduced for the refrigeration system is bled off from where the air is coming. The air is coming after ramming. It will coming from the main compressor, where some of the air again passing through the combustion chamber, where combustion will take place, and some this combustion will helping in running this gas turbine. And this gas turbine is directly connected to the main compressor, which is running this main compressor. After some of the air, when it will pass through the heat exchanger, look at here. So this is your heat exchanger. Okay, so this means the temperature of this air is very, very high. So to reduce this temperature of this air, the rammed
The
air
screen is not visible.
Beta, who is speaking?
Harman sir.
Screen is not visible.
Yes sir.
Now tell me,
Yes sir. Now visible.
is it visible?
Yes sir.
Okay. So better look at it. After when this air is passing through this rammed air, first cooled with the help of this cooling turbine. So this is the cooling turbine. With the help of we will decrease the temperature of this rammed air first. So this cooling air when passing through this heat exchanger, then it will take away the heat from there. Okay, and this the rammed air is going to the atmosphere. Look at it through this pipe. You can see. And when the temperature of this air is getting reduced in a heat exchanger, after this, it will passing to the second heat exchanger. Where is my cursor? Look at here. When it will passing through the second cooling turbine, its a temperature and pressure both get decreased here. Okay. Then it will supply to the air to the cabin. So look at here. Where is my cursor? Here the air is supplied to the cabin. From where it will take the heat load. After taking the heat load, it will supply again to the atmosphere. So look at here in this diagram, there will be only one heat exchanger in between two cooling turbines. Okay, so such type of system is known as reduced ambient air cooling system. And this for cooling turbine also used in running this cooling fan through this reduction gear. So with the help of reduction gear, we can decrease or increase the speed of this cooling fan. Okay, so reduction gear means we can reduce the speed of this cooling fan. Okay, so this is the figure of a reduced ambient air cooling system. So everybody draw this figure. Are you note on? This type of system is used for very high speed aircraft. Look at here. This type of system is used for very high speed aircraft. Okay. When ram pressure is too high. So look at here. Why this cooling turbine is used? Because here in this case, ram air pressure temperature is very, very high. So when ram, because your very high speed jet aircraft is passing, so the temperature of rammed air is very, very high. So first we have need to cool down the temperature of the ramming air. So that's why we will place over here a first cooling interval. Okay, so this is mostly used in very high speed aircraft. Everybody note down it. Hurry up. Now I am moving to the TS diagram. So this is all about the TS diagram. So look at here. 1 to 2 ramming action will be there. Okay. This is the isentropic ramming action, actual ramming pressure from 1 to 2 dash. After this, it will passing to the heat exchanger. It will pass it to the compressor where both pressure and temperature will get increased. Okay. Then it will passing through after through the first heat exchanger, which is cooled with the help of cooling turbine. So 3 dash to 4 is the temperature is reduced in the heat exchanger. Okay. After heat exchanger, it will passing through the cooling turbine from 4 to 5. But due to internal friction, its pressure and temperature reduced from 4 to 5 dash. Note actual pressure and temperature reduced from 4 to 5 dash. After this, again passing through this cooling space cabin, where it will take the heat load and its temperature increase from 5 dash to 6. After taking the heat load from there, it will again supply to the surrounding. So this is the diagram of the reduced ambient air cooling system. So everybody note down this diagram. Hurry up. Now next is your regenerative type air cooling system. So look at here in this system, again ambient air entering into the jet where ramming action will be there, where both pressure and temperature get increased. After ramming action, it will passing through the first main compressor, then again after passing through combustion chamber, it will helping in running this gas turbine, which is directly connected to this main compressor. Okay, and some of the air will passing through this first heat exchanger. So this is the modification of the simple air cooling system. Okay, so when it will passing through the first heat exchanger, it will its temperature is reduced with the help of this ram air. Okay, now after this, there is a second heat exchanger is called a regenerative type heat exchanger. Look at here. This is called your regenerative type heat exchanger. So when your air is passing through a regenerative type heat exchanger, which is cooled, this regenerative type air heat exchanger is cooled with the help of the air which is coming after passing through this cooling turbine. So some of the air will go to the atmosphere and the remaining air will passing through this regenerative type heat exchanger. When some of the air is passing over regenerative heat exchanger whose temperature is much lesser than the air which is passing through this regenerative type heat exchanger. So this means this type of air is used whose pressure and temperature is very much lesser than the temperature of the air which is passing through this regenerative type heat exchanger, which is cooled first with the help of this cooling turbine. So whose after cooling turbine, whose pressure and temperature is much lesser than the temperature of this regenerative heat exchanger. So this air is utilized to remove the heat in the regenerative type heat exchanger. So this cooling turbine again running this cooling air fan, which is helping to overflow this ramming air flow over the pipe of this first heat exchanger. Okay, so this is all about this regenerative type air cooling system. So everybody draw this figure. Hurry up. And everybody try to draw the TS diagram of this regenerative type air cooling system yourself. Hurry up. Everybody try to draw this the TS diagram and show me. Hurry up. Show me here. Everybody draw the TS diagram of this regenerative type air cooling system. Hurry up. So this type of regenerative air cooling system is mostly used in supersonic aircraft. Supersonic. It is mostly used in supersonic aircraft and in missiles. Okay, as you everybody knows, supersonic missiles are also there and supersonic aircraft are also there. So this type of regenerative type air cooling system is mostly used in supersonic aircraft or and in missile, supersonic missile. Okay. So we will draw this TS diagram of this regenerative type air cooling system. Hurry up. But everybody draw the TS diagram first. Hurry up. So look at here. This is the TS diagram. Again, 4-5 pressure are there: ambient pressure, cabin pressure, actual ram pressure, ideal ram pressure, and mean compressor pressure are there. Okay. So for 1 to 2 is your ideal ram pressure, 1 to 2 dash is your actual ram pressure, 2 dash 3 your isentropic compression, and 2 dash 3 your actual compression in the main compressor, and 3 dash to 4 when it will passing through your heat exchanger, 3 dash to 4, and 4 to 5 when it will passing through your regenerative type heat exchanger, 4 to 5. So look at here, 4 to 5. This is when it will passing through the regenerative type heat exchanger. Okay, so at the bottom, look at here, where 5 to 6, again when it will passing through the cooling turbine due to internal friction, actual turbine expansion from 5 to 6 dash. This much temperature is reduced. Not this much 5 to 6. This much temperature is not reduced, but actual 5 to 6 dash due to internal friction. Some of its pressure will get increased due to internal friction. And after this, it will passing through your cooling turbine cabin. From it will take the heat load. After taking the heat load from 6 dash to 7, its temperature is going to increase from 6 dash to 7. Look at here in this diagram. After this, when it will taking the heat rate and its temperature is going to increase up to 7, then it will supply to again to the atmosphere. So this process is repeating again and again. New fresh air is coming inside, and after taking the heat load from the cabin, it will again supply to the atmosphere. Okay, so this is all about the diagram of the regenerative type air cooling system. Okay, so now draw this diagram. Everybody, hurry up. So beta, in this case, look at air. From this diagram, some air is going to the atmosphere and some air is going to the regenerative. So here you can calculate the air which is passing to the cabin. That air will be M2 Cp into T8 minus T6 dash. How much air is passing through the cabin? Okay, that air will passing to the atmosphere. That atmosphere air temperature is T8. So here M2 into Cp T8 minus T6. If I will energy balance the equation, that will be equal to M1. That will supply to the heat regenerative heat exchanger. That will be equal to M1 Cp into T4 minus T5. T4 minus T5. So look at here. This T4 minus T5 is passing through this regenerative type heat exchanger. So the M1 will be equal to, so in this case, you can calculate the value of M2. So from here, from energy balance equation, look at here. Look at here on the blackboard. How much air is passing to the M2 into Cp? That will passing to the atmosphere. How much air which is passing to the atmosphere is T8. T8 is the temperature which is going to the atmosphere. Minus how much refrigeration factor will be there? T6. Or in this case T7. Okay. So in this case, T8, how much air is going? T9, here T9 and here T7. Okay. Then how much air is regenerative? Regenerative action will be there. This is not the diagram. Okay. So diagram, from that diagram, that will be equal to M2 into Cp T8 minus T6 dash, which will be equal to M1 into Cp T4 minus T5. So from here you can calculate the value of M2. How much air is going to the atmosphere and remaining air will pass into the your regenerative type heat exchanger. So from here you can calculate the value of M2. That will be equal to M1 into Cp T4 minus T5 divided by Cp into T8 minus T6 dash. So this is the formula. How much air is passing through this your regenerative type heat exchanger? Remaining everything is same. Okay, remaining everything is same. So you can calculate the value of mass of air. That will be equal to 210 into Q divided by Cp T7 minus T6 dash. Okay, from your TS diagram. and power from the main compressor and COP 210 into Q divided by P into 60. That will be same. Only you can get the calculate the how much air is passing through the regenerative type heat exchanger from this formula. I have already written on the blackboard. Okay. Now I am going to stop it and I am going to release very first code. Everybody answer it. Take your time and give me the correct answer. 1 minute time is there. Hurry up. Beta, I am going to close this poll. 64% already voted. Remaining, hurry up, please. Voted, please, hurry up.